Hi kids, here comes objective number 60. This is kind of a review lesson, bringing a lot of things together in a different way, not necessarily any new information. So if you've been needing a break with all this new information, this might be good for you to kind of piece all these things together and see how they work. So today we're on objective 60. We're going to both represent, so here's 4 different representations, and compare functions numerically. I used a table today. Let's see, graphically, verbally, and algebraically. In a previous lesson we talked about how a function can be represented in all kinds of ways. Other ways that you don't see here are as coordinates, or as horizontal tables, or as real world, like what we call word problems. And so these are just 4 of the representations that we are going to use for functions. And so if you take a big look at your notes page, you will see that there are 4 examples. And for each example, I have provided a different form of information for you. So I'd like to show you how you can find or fill in a table, a graph, and a verbal model just with an equation, or how you can use a table to find an equation, a graph, and the verbal explanation, or you can use the graph to find the other 3, or the verbal description to find the other 3. So here we go. Let's start with y equals 3x plus 2. So in this function, these are our inputs. All right, so we're going to put, for example, y equals 3 negative 1s into the machine to see what we get out for our output for our y. Y equals negative 3 plus 2. Y is negative 1. So negative 1 goes there. Negative 1 comes in, negative 1 goes out. Let's try another. Y equals 3 zeros plus 2. Any number of zeros is 0, plus 2 is 2. 0 in, 2 out. Y equals 3 1s plus 2. 3 1s is 3, plus 2 is 5. If your work goes all over the place, that's fine. I don't care. And so now, from here, we can graph. We have a table, but this table is also a list of coordinates. Look at there. Remember, a coordinate is made up of an x and a y. In a coordinate, the first number tells you the horizontal distance from the origin, and the y tells you the vertical distance from the origin. And of course, up is positive, right is positive, down is negative, left is negative. So if I have this point, negative 1, negative 1, that means from the origin, down 1, I'm sorry, left 1, down 1. So left 1, down 1. Here, there's no horizontal movement, and 2 up. 0, 2. And then 1, 5. Right 1, up 5. Right 1, up 5. And so we have 1, 2, 3 points. If you have a straight edge, use that, and then connect the dots. So this means the same thing. All of these represent the same thing, just in a different way. And so now we can do the verbal part. This function, it multiplies. There's our first operation. Multiplies. That's an interesting way to spell that. I think that's right. It's really hard to think and talk and write and hold a phone at the same time. Multiplies the input by 3. So that's this part, and then adds 2. All right, so that's our first example. Now we're going to do the same exact thing. We are just going to use a different form of representation to start with. So here we have a table. Remember, we could write that same information as a sequence, negative 6, negative 4, negative 2, and we can write an equation out of this. So what's my change as I go across? I'm increasing by 2, so y equals 2x. And my first number is negative 2. What do I do to positive 2 to get to negative 2? I subtract 4. That makes sense. I have a 0 and a negative 4. My starting spot is negative 4. Great, so that's the equation. And you can test that out on several of your points to make sure that's correct. Now knowing that, again, you can turn these into coordinates and graph them. So -1, -6 means 1 left, 6 down from the origin. 0, -4, no horizontal movement, 4 down from the origin. And 1, -2. Draw a line. And so this is a graph of that equation. So this function, again, multiplies the input by 2. Sorry, I meant to leave that as a blank. Pretend it's a blank. 2. And then subtracts 4. Great. Hey, that was fun. Let's do another one. All right, here we go. Now we have a graph. And from that graph, we can go backwards and fill in our table. With -1, we had positive 1, 2, 3, 4. Up is positive, remember. 0, 0, and 4, -4. So again, if I look at this sequence here, if I'm going from 4 to 0 to -4, I'm subtracting 4 each time. That's repeated addition, which is multiplication. So y equals -4x. And if I look at this 0, 0, I can see that this time my starting spot was 0. Or you can say, what do I add or subtract to -4? To get to -4, nothing. So I'm going to leave it how it is. All right, so what does this function do? It multiplies the input by -4. Don't always have to have, a number of x and then plus or minus something. Just -4x is fine on its own. And now, just to keep things interesting, we have a different kind of equation that we haven't seen so far. This function, did not mean to say doubles, squares. Now we have a different kind of function. Squares the inputs. This was meant to be filled in on your worksheet like so, and this information wasn't supposed to be there. If you were in my class, you got a goofed up notes page. If you are doing this after the fact, you should have a nice new corrected one. So if I have -1, 0, and 1, if I square -1, -1 times -1 is +1. 0 squared is 0. 1 squared is 1. What? I have 2 positive 1s, and that's okay. I'm going to graph it like so. Whoa! We have it looks like a V. This is actually the beginning of a parabola, which we are going to learn about in a couple weeks. And so, this is a different kind of equation. Y equals something's happening to our x. It is being squared. Remember that square is an exponent of 2, so we'll just write 2, x squared. So again, that's just showing you how you can represent a function a lot of different ways. These are just 4 of the ways, and also how you can fill in the information for the functions starting with different forms. So your homework is a matching activity. And so on your homework, you have 4 different equations, and they are lettered A, B, C, and D. And so what you will do is look at the first one. A. It says y equals 2x. Which of these tables works when you put -4, 0, 4 in for x to get the particular output that's listed for y? So 2x means multiply the input by 2. So -4 times 2 is not -6, so it's not that one. -4 times 2, is -8. 0 times 2 is 0. 4 times 2 is 8. Yeah, so this is also an A. And then these are your 3 coordinates here, which you will match with a particular graph, which you will label with A. I don't want to give that one away because there's not too many ones not too many opportunities to practice, but I will give you a hint. This one has 0, 0 in the middle, so you know whichever graph it is, the line is going to go through the origin, so it's one of these two. And then, does this function divide the input by 2? We didn't just divide. Does it multiply the input by 2? Does it double and then add 2? Does it subtract 2? So you tell me which one it is and put A on that line. And then you'll repeat the process with B. Y equals 1/2 times x, or y equals x divided by 2. It means the same thing. So find the table that matches that. Match that table to a graph, and then do match those responses with the verbal model of what you've just done. So I hope that helps. Again, these are not meant to replace a lesson. They're just meant to help you if you get stuck, if you've been absent. I'm always happy to help. If you need me by email, you can send me an email at drones@d231.rochelle.net. All right. Look at this. I put my cat to sleep. I'm so boring. All right. Bye, guys. Thanks a lot. Get a hold of me if you need help. See you tomorrow.